Now we are going to take up the one more problem, the problem number 40. How to analyze this problem and solve by using the sketchbook. A line capital AB 60 mm long has one of its extremities 20 mm in front of VP and 50 mm above HP. The line is inclined at 25 degrees to HP and 40 degrees to VP. Draw its top and front views. So the problem is given. Now we need to analyze this. So to analyze this, we have a line capital AB 60 mm long has one of its extremities. One of its extremities means what? So this one of its extremities is the one which we talk about is one end of the line. He says it is 20 mm in front of VP and 15 mm above HP. So when you are looking from the front view, if you look from here, so this is the front view. Then what happens? The distance above HP can be seen that as we look from the front view, the distance above HP, this distance is seen here in the vertical plane. So that means when you are projecting this, you are going to get it like this. So it is 15 mm above HP, it is going to be seen in vertical plane, which is A dash. Then similarly, as you look from the top view, you can look from the top view. As you look from the top view, you can see the distance in front of VP. Which is the distance in front of VP, that is from here to here is the in front of VP. As it is look from the top view, the projector will going to be down and falls on HP. And this point is small a, which is 20 mm in front of VP and 15 mm above HP. So you got A dash and small a. And as he says that the line capital AB 60 mm long has inclined at 25 degrees to HP. So that means he has given the true inclination of the line. So true inclination is what? It is the true length and inclination. So that means you take 10 mm and 20 mm, 15 mm above HP. So from here, so this is 15 mm above HP. And from here you draw a line which is inclined at 60 degrees for 25 degrees to HP. And this point will be capital B1. And as we look from the top view, you can see the distance which is in front of VP. Both the distances, both the endpoints are equidistant from the vertical plane. So now the line is parallel to VP. Since the line is parallel to VP, so therefore you will be getting the true length in the vertical plane. So you are getting the true length here. So if you understand the concept of this by considering the rule, so that means as it is parallel to in front of VP, so as it is 20 mm in front of VP, both the endpoints, as it is been projected, it will going to come on A and B1. So the line, the end A is in front of VP by 20 mm and end B1 is also in front of VP by 20 mm. So when you keep it in space, you are going to get it as that line as capital AB1. As you look from the front view, it falls on the vertical plane here. So A dash B1 dash is the line which is the true length, which is inclined at 25 degrees to HP. You can see here. But as we look from the top view, the image will going to fall on the horizontal plane. So A is in front of VP by 20 mm and B1 is also in front of VP by 20 mm. So that is quite evident. From where? From here. You can see XY line and VP and HP. You have A dash and we have A, and that line is inclined at 25 degrees to HP. So A dash B1 dash is the line which is the true length and its inclination is 25 degrees. So as we know that it is the true length line, so obviously that line should be parallel to XY in the top view. So that means A is in front of VP by 20 mm and B1 should also be in front of VP by 20 mm. So that is the reason why you can see that AB, this distance is 20 and this distance is also 20. As you look from the top view, this will going to have the horizontal line. So that is the reason why as we project from the B1 dash, you are going to get till to the locus of A in the top view. Now the line is parallel to AB1, so that is parallel to XY line. If the top view line is parallel, its corresponding front view, which is A dash B1 dash, is in true length. So this is how you will be able to analyze this for the one part of this question. Now what we want to do it for the second part of the question. What is that? The line is also having a length of 60 and inclined at 40 degrees to VP. So again he says it is the true inclination line with respect to VP now. So you can see here that it is represented in space with capital A and B2. As we see from the front view, both the ends are at equidistant from the horizontal plane. That is, A is above HP by 20 mm and B2 is also above HP by 20 mm. Therefore, the line is parallel to HP. As we see, the line is parallel to HP, so you are getting the true length in HP here, AB2, as we project. But when you look from the front view, both A and B2 are equidistant from the horizontal plane, so it becomes a horizontal line which you can see A dash and B2 dash, which is here. So now the line is parallel to HP. Since the line is parallel to HP, so we are getting the true length in HP. So you can see. So where we are going to see that line when it is parallel to HP, the image will going to fall on the vertical plane. Therefore, you have to look in the vertical plane. Now, in the vertical plane, A dash B2 dash is parallel to HP. So therefore, you are going to get the true length in HP. How do I identify that here? You can see, as we see the line which is inclined at 40 degrees to VP and having a length of 60, because we know that the true length of the line is same in both in front view and as well as in the top view. So once you get this AB2, so you get the locus line in the top view and you have got the locus of B in the top view or in the front view. Now we know that this is the true length of the line in the top view, which is AB2. And we know that it is the true length in the horizontal plane, therefore the line has to be parallel to HP. So where you are going to get the line parallel to HP, which will be seen in the vertical plane. As we see now, the line is parallel to HP, that is seen in the vertical plane, which is A dash B2 dash. Now here from B2 you just project that point till the locus of A, which is there in the front view, which is both the points are at 15 mm above HP. Now the line is parallel to HP. As the line is parallel to HP, so you are getting the true length in HP, so AB2, which will be capital A and capital B. Now due to the presence of the locus of B in the front view is here, so what should I do now? So that B2 should be transferred to this, and also the locus of B in the top view is here, so this B1 should be transferred to this. So then with A dash as center and taking the radius of A dash B2 dash, you rotate it so that it is going to cut the locus of B in the front view here, and you mark this point as B dash and join A dash B dash with a dot line. Similarly, with A center taking the radius of AB1, you draw an arc so that it is going to cut the locus of B in the top view, and you name that point as B and then join A to B with a dot line. And when you join between A and B and B dash, both will going to lie on the same line. So that is how you will be able to infer that your problem is right. So now as we see where exactly this you are rotating, now you can see the rotation concept now. So here with A center taking the radius of A dash AB2, you rotate it such that B will going to cut the locus of B in the front view here. So that is the reason why when you are rotating, you can see when you are projecting that point, both B dash and capital B will going to be on the same line. As we start rotating here, what happens? The image will going to be get rotated, that is from here to here. So it cuts the locus of B in the front view. You mark that as B dash and join A dash B dash with a dot line. Similarly, you take the true length of the line or the top view of the true length of the line in the that is the top view of the true length of the line which is on VP. So as we rotate with A center taking the radius of AB1, you rotate it such that it will going to cut the locus of B in the top view here. So what happens to the image? Image is also being get rotated as we see that B1 and small b1. When you are rotating that B1, see what happens, that AB1 will going to come and touches this point here. So this is how, and then join capital A and B, which is a line which is in space, which is the case of the line inclined to all the three planes. So this is how we will be able to analyze this problem in both 2D and as well as in 3D. Now we will going to try to solve, but before that we will just go to this and we see how exactly it has been taking place. So here we have considered the true inclination line in the front view and also the true inclination line in the top view. So we know that it is the true length of the line in the front view. Obviously that line has to be parallel to xy in the top view. So A is in front of VP by 20 mm and the B1 should also be in front of VP by 20 mm. Therefore, you project this point directly onto the locus of A in the top view here. Because due to the presence of locus of B in the top view, which is at certain distance from here to here, so obviously, so what I should do now, with A center taking the radius of AB1, you rotate it so that it will go to cut the locus of B in the top view. Then join A and B with a dot line. That is what we have shown. I have rotated this in space such that it will going to come, that B1 will going to come and touches this point. So that means you are going to get the locus of B here. So you are going to get B, that is the top view. So similarly, what we can do is we will going to consider the front view now. You take the true length in the top view and then we need to get the front view now. So how to go about of doing that? So here you just project, as you know that it is a true length in the HP because it is capital A and capital B, you just project this point till to the locus of A in the front view, that is A dash B2 dash. Then with A dash center taking the radius of A dash B2 dash, you draw a circle so that it is going to cut the locus of B here. And you join A dash B dash with a dot line and remove all other things. So this is how you will be able to analyze. So as we see here, with A center taking the radius of AB2, you rotate it so that this B will going to touch this locus of B in the front view. So what happens when it is rotated in space, it will, the image is also being get rotated, that is from here, it is start rotating so that it will going to cut the locus of B in the top view, in the front view. You mark this as A dash and B dash and join with a dot line. So as we project that both B dash and capital B will going to be on the same line, but due to having the better clarity, just I remove that particular line. As we have seen here, I have shown that line here from the reference. So this is how you will be able to analyze this problem in both 3D and as well as in 2D in step by step. Now what I want to do now, I want to see how we can write by using the sketchbook. So to do that, first we are going to draw the XY line and you mark XY and identify the planes VP and HP. As we see that it is rotate, we are solving the problem in the first quadrant. So in the first quadrant, the vertical plane will be above XY line and the horizontal plane will be below XY line. So here one of its extremities is 20 mm in front of VP and 15 mm above HP. So from the XY line you measure 15 mm and draw a horizontal line because as you see above HP, so the image has to be in VP. So then similarly 20 mm in front of VP, so in front of VP will be seen in HP. So from XY line you measure 20 mm and draw a horizontal line. You take any point on these two lines, take any point on the line which is drawn in the vertical plane, and then from there you draw a perpendicular to the line which is drawn in the top view, which is perpendicular now. So then what we need to do now, we need to identify the point which is A dash and small a. Then you write capital A here and capital A here as one of its extremities, and the line is inclined at 25 degrees to HP, since it is the inclination given is with respect to HP. So obviously what happens, that point will going to be, and that point that line will going to be here. So that is that point will going to be here A dash. By using the protractor you measure an angle of 25 degree with respect to the horizontal and then draw an inclined line. Similarly with A center, measuring the angle of 40 degrees with respect to the horizontal, which is below the horizontal line, and mark this point and then draw an inclined line. So one should do that at 40 degrees, and as we see it is 60 mm long. So the true length is same in both front view and as well as in the top view. So what you can do is with the A dash center, so then taking the radius of 60 mm by using the compass, we cut an arc on that 25 degree line and you mark this point as B1 dash. Similarly with the same radius with A center, cutting it on 40 degree line, and you will going to get this point as B2 and you mark them as B1 dash and B2. And you write capital B here and capital B here. Once you do that, then you draw a horizontal dashed arc line which will going to be the locus of line in the front view, and this will going to be the locus of line in the top view. Why we need to understand this? Because the front view line should lie on this line, and the top view line, the top view point should also lie on this locus of B in the top view. So how to go about of doing that now? So here, as we see that first we are going to consider A dash, B1 dash, and you write capital A and capital B, and here you have the locus of B. Similarly, you mark this point as A and you mark this as point as B2, and you write it as capital A and capital B, and this is the locus of B. As we see that we have considered the true length in the front view, obviously that line should be parallel to XY line in the top view. So draw a vertical thin projector line from B1 dash such that it will going to cut the locus of A in the top view here. So you mark this point as small b1, and again with A as center, taking the radius of AB1 by using the compass, you draw an arc such that it will going to cut the locus of B here. Then you mark the point as B and join A to B with a dot line. Similarly, we want to draw the same thing by using the front view now. As we see that it is the true length in the top view is AB2, you take that end of B2, you take and draw a vertical projector such that both A dash and B2 dash above XY line by 15 mm. So then only the line will be parallel to XY. As we say that the top view of the line is in true length, so obviously the corresponding front view, which is A dash, B2 dash, should be equal to parallel to XY. So then draw a vertical projector from B2 to above HP by 15 mm line. Then you mark that point as B2 dash with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will go to cut the locus of B in the front view here, and you mark this point as B dash, then join A dash B dash with a dot line. How do I know that my problem is right? You can draw a vertical projector from B dash, it will go to intersect directly with the point B, so that when you click on this and if you try to check the vertical line, it will be exactly 90 degrees. As you have seen, draw its top and front view, so therefore we are writing the draw and front view only. We are not draw the top and front view, but we have, since you are not given to find out any inclination, but you show the dimensions. You show 15, 20 and then 40 degrees, then 25. Then you take the true length of the line as 60 and you mark this as angle alpha, and you mark this as angle beta. So this is how you will be able to analyze both in 3D and as well as in the orthographic view, and also how to solve the problem by using the sketchbook. Thank you.